Suppose you're searching for a word in an actual physical dictionary. Yeah, some people still use those. If you're looking for the word mustache that starts with M, you could start at the beginning and keep flipping pages until you get to the M's. But you're more likely to start at a page in the middle, because you know the M's are going to be near the middle of the book. Now suppose you log on to Facebook. When you do, Facebook has to verify that you have an account on the site. So it needs to search for your username in its database. Suppose your username is Mustache Man. Facebook could start from the A's and search for your name, but it makes more sense for it to begin somewhere in the middle. This is a search problem, and both of these cases use the same algorithm to solve the problem: binary search. By the end of this module, you will understand the concepts behind binary search. Also, you will be able to implement a binary search in Python. Binary search is an algorithm and its input is a sorted list of elements. If an element you're looking for is in that list, binary search returns the position where it's located. Otherwise, it will return null. Let me give you an example about how binary search works. Let's say you have a number between 1 and 100, and you have to try to guess the number in the fewest tries possible. With every guess, I'll tell you if your guess is too low, too high, or correct. The bad way would be just to start from the beginning. Is it 1? Too low. Is it 2? Too low. Is it 3? And so on. This could take a while. That is called simple search, and if the number was 98, it would take 98 guesses to get there. A better way would be to start with 50. Is it 50? Too low. Too low, but you just eliminated half the numbers. Now you know that 1 through 50 are all too low. Next guess, 75. Too high. Again, you cut down half the remaining numbers. With binary search, you guess the middle number and eliminate half the remaining numbers every time. And now you just learned binary search. Whatever number I'm thinking of, you can guess in a maximum of 7 guesses, because you eliminate so many numbers with every guess. Let's say you're looking for a word in the dictionary, and the dictionary has 240,000 words. Simple search could take 240,000 steps if the word you're looking for is the very last one in the book. With binary search, you keep cutting the numbers of words in half until you're left with only one word. So binary search will take 18 steps. A big difference. In general, for any list of n, binary search will take log base 2 of n steps to run in the worst case, whereas simple search will take n steps. One thing to keep in mind for binary search is that it only works if the list is in order. Let's do a quick review of logarithms, since they are often used when describing how long algorithms take. Just like multiplication is the opposite of division, logarithms are the opposite of exponents. Log base 10 of 100 is like asking, how many 10s do we multiply together to get 100? The answer is 2, so log base 10 of 100 equals 2. If you look at this chart, you can start to see how exponents and logarithms are related. In this series, whenever you hear log, it means log base 2, which is what these are. For binary search, you have to check log of n elements in the worst case. So if you have a list of 16 elements, log of 16 equals 4, because 2 to the power of 4 equals 16. If you want to learn more about logs, check out the video about logarithms on Khan Academy. So let's see the actual code for binary search in Python. This code uses arrays. Arrays store a sequence of elements in a row of consecutive buckets. The buckets are numbered starting at 0, so the first bucket is 0, the second is 1, and so on. The binary search function takes a sorted array and an item. If the item is in the array, the function returns its position. So for example, if I pass in this array into the binary search function as the list, and then I pass in item 20, the function will return 1 because 20 is at index 1. First, we'll create low and high to keep track of which part of the list we'll search in. So low is going to start at 0, and high is just going to be the length of the list minus 1. Since the buckets of an array starts counting at 0, the length of the list minus 1 is the last item in the list. So here's where we start the while loop. While low is less than or equal to high, that just means while we haven't narrowed it down to one element, we're going to check the middle element. So mid is going to equal low plus high divided by 2. These two slashes just mean integer division. That just means it's going to get the answer without a remainder, basically rounding down to the nearest whole number. So we're going to guess the middle element in the list, and if the guess equals the item, we found the item. So we're just going to return mid, which is the index with the item. If the guess is more than item, then the guess was too high. So we're going to set the high to the mid minus 1. This basically cuts off the top half of the array, so we're only going to look in the bottom half of the array now. Else, the guess was too low. So we're going to set low to mid plus 1. So that basically cuts off the bottom half of the array. So we're only going to look at the top half of the array. And we're going to keep going through this while loop until guess equals item, until we find the item, or low is less than or equal to high, which means we didn't find the item. So at the end, we're going to return none. That just means the item doesn't exist. So let's try this out. We're going to set my list to equal an array with 1, 3, 5, 7, and 9. Now we're going to print the result of calling the binary search function. We're going to pass in the list we just created and the number 3. And then we're going to do it one more time. We're going to pass in the list and the number -1. So if you see up here, the first thing it prints is 1 because 3 is at index number 1. So it starts at 0 and 1. The first thing it prints in the console is 1. And then it prints none because -1 is not in the list. And that's binary search.